It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. All right, welcome back, undergraduate software engineering students, to the Week 05 explainer for the SWE 4304 Databases course. So you've spent the last few weeks capturing requirements, writing business rules, and getting your basic entity relationship diagrams, your ERDs, off the ground. But today, we're shifting gears. We are focusing strictly on the design stage. No SQL querying just yet, because we need to make absolutely sure the very foundation of your database is rock solid. Think of it like building a skyscraper, right? If your blueprints are fundamentally flawed, no amount of fancy interior decorating or, complex SQL queries in our case, is going to keep the whole thing from collapsing. We really have to get this right before we start building upward. So let's dive into this. Is your basic ERD actually enough? I mean, standard entities and relationships are a fantastic start. But what happens when your data gets really complex and starts sharing overlapping traits? Sometimes a basic entity box just isn't descriptive enough to capture the highly nuanced business rules of the real world. For example, picture a hospital database. A person entity might need to act as a patient, a doctor, or somehow both simultaneously. Each of those roles requires totally different types of data tracking. If you use a basic ERD, you might find yourself constantly repeating attributes across multiple tables, or just struggling to show that certain relationships only apply to specific types of a broader entity. And that is exactly where our focus for this week comes in to rescue your design. Here's the game plan for today's explainer. 1. Why enhanced ER modeling. 2. Supertypes, subtypes, and inheritance. 3. Mastering ER subtype constraints. 4. Validating with view integration. 5. Crash testing your design. And 6. Your Week 05 assessment goals. Okay, section 1. Let's start by looking at why we might actually need to level up our designs to version 0.4 with enhanced ER modeling. Look, the crucial point here is that enhanced ERD or EER isn't just about making your diagrams look more complicated so you can impress your professors. It's a really precise toolkit designed to add clarity, but only when it actually adds meaning. We use EER features to handle specialization and generalization in our conceptual models. It lets us intuitively express complex inheritance structures and data constraints the basic ERDs literally just cannot handle. But, and this is a massive but, you have to justify it every single time you use it. You can't just throw an ER element onto the canvas because you think it looks cool. In fact, remember this golden rule straight from your tutor guide. Do not add complex features just for the sake of using them. No unnecessary subtypes. If splitting an entity into subtypes doesn't actually result in unique attributes or unique relationships for those specific subtypes, well, then you probably don't need them. You want to keep your brilliant design as simple as possible and only as complex as strictly necessary. Because if you ignore this rule, over-engineering your database now is going to result in absolute headaches and incredibly convoluted code when you actually start writing queries later. Let's just save our future selves some pain, right? All right, section 2, supertypes, subtypes, and inheritance. This is where we get into the actual mechanics of EER. Think of supertypes and subtypes as the ultimate way to elegantly handle that specialization and generalization we just talked about. A supertype is your big general category. Let's say a user logging into a university system. A subtype is a specific categorization of that general concept, like a student or a staff member. You use this incredibly helpful structure when these subgroupings have unique attributes that don't apply to the whole group, or when they participate in distinct relationships. For instance, a student entity actively enrolls in a course, but a staff entity teaches a course. The supertype user doesn't do either of those things universally, so treating everyone just as a generic user would completely break your business logic. And this concept brilliantly illustrates how inheritance saves you from modeling the exact same attributes over and over again. If your user supertype has standard email and date of birth attributes, your student and staff subtypes automatically inherit those. It's exactly like genetic inheritance, but, luckily your subtypes only inherit the highly useful data, not your bad eyesight or your terrible dad jokes. Because of this, you don't redraw those shared attributes. You only ever add the unique attributes to the subtypes themselves, like a staff ID specifically for staff, or an enrollment date specifically for students. It makes your entire model incredibly clean, wonderfully efficient, and totally logically sound. Moving right along to section 3, mastering EER subtype constraints. Once you have supertypes and subtypes, you need to establish the rules of the road. So let's break down the first vital set of specialization constraints, disjoint versus overlap. When you build subtypes, you have to tell the database exactly how instances are allowed to behave. If a rule is disjoint, a single record in the supertype can only ever be one of the subtypes. Picture a standard bank account. It might be either a checking account or a savings account, but one single account is never both at the very same time. Overlap, however, means an instance can legally be both simultaneously. Think back to our university example. A user could absolutely be an alumni and current staff at the exact same time. These constraints let you express vital, non-negotiable business rules directly in your diagram. Now, let's look at the second set of constraints, total versus partial. These dictate whether subtype membership is absolutely mandatory. Think of a total constraint like a strict sorting funnel. Every single entry in your overarching supertype table must fall into one of your specific subtype buckets below it. No generic leftovers allowed. Everyone gets sorted. With a partial constraint, though, an entry can just peacefully exist in the generic supertype without fitting into any of the highly specific subtype boxes. Maybe you have a generic guest user who doesn't fit into staff or student. Getting these constraints perfectly right is a massive part of your Week 05 learning outcomes. Okay, section 4, validating with view integration. We are now pivoting from building the model to, well, trying to break it. A design isn't finished just because it looks nice on the screen. View integration is your definitive tool to strengthen the conceptual model by making completely sure all your different user perspectives align perfectly. Remember when you gathered requirements back in Week 02? You probably looked at the system from the specific view of several different users. View integration is the critical moment where you merge those differing perspectives. Let's say your marketing team confidently talked about a client, but your tech support team kept talking about a customer. If you blindly model both of those perspectives without thinking, you've just created a duplicate entity for the exact same real-world person. View integration forces you to spot these inconsistencies, negotiate a single crystal-clear definition across departments, and merge them, preventing messy definitions later on. Which brings us to section 5, crash testing your design. This is how we prove the design actually works for the business. You can absolutely think of this step as a rigorous crash test for your model. You're going to draft your CRUD transactions, enthusiastically run them against your model, and meticulously log exactly where the design fails. CRUD, of course, stands for create, read, update, and delete. You absolutely need to test all 4, because think about it, a database that lets you brilliantly create a record but never actually update it later is literally useless in the real world. You want to write out 6 to 10 highly realistic actions a user will definitely take. For example, a manager securely updates a customer's premium subscription. Then physically trace your finger over your ERD. If a manager updates a subscription, do you have a manager entity? Is it correctly connected to a subscription entity? Can the data legally flow between them based on your relationships? If not, you've just found a major gap in your model that desperately needs fixing. And here is exactly how you want to document this. When you write your validation notes, which, by the way, is incredibly critical for your assessment, you must structure them methodically. Log the specific issue you just found during your crash test, explicitly state the exact CRUD transaction that exposed that flaw, detail the specific change you just made to your ERD to fix it, and most importantly, deeply justify why that change improves the overall conceptual model. Honestly, doing this right now as you find the errors is going to save you hours and hours of frustrating writing when you're packaging your final comprehensive report. Finally, section 6, your Week 05 assessment goals. Let's make sure you know exactly what is expected of you. Listen up, because this is your literal checklist for your grade this week. Make absolutely sure these 3 specific artifacts are safely saved in your A1/A2 working folder before the week's end. 1. Your ERD should now officially be at version 0.4, fully incorporating any strongly justified supertypes, subtypes, and those disjoint or overlapping constraints we discussed. 2, alongside that diagram, you critically need your plain English list of 6 to 10 CRUD transactions. And 3, that beautiful, deeply methodical validation notes table we just walked through. These are major, unskippable milestones for your Assessment 1 design evidence. So as you carefully build your version 0.4 ERD this week, I want you to constantly ask yourself, does this specific subtype actually add clarity or just visual clutter? Your ultimate goal as a database designer isn't to build the absolute most complex diagram possible, it's to build the most resilient, logically sound one. Because if your conceptual model crumbles under the moderate weight of a simple CRUD transaction today, what happens when millions of rows of live, critical user data are poured into it tomorrow? Capture that rigorous validation evidence, aggressively solidify your foundation, and I'll catch you in the next explainer.